welcome Rene. Rene is developer and maintainer of the LINSTOR plugin for CloudStack, and he's going to tell you about what's new. Thank you, Rene. Please welcome.
Hello. Yeah, hello. So my name is Rene. I'm working for Linbit since now 6 years and 2 days. Most of the Linbit developers are based in Austria, so I'm living 7 or 60 kilometers south of Vienna. Hello. Okay. Yeah. So before I start with what's new, I give you a bit of an introduction of what is LINSTOR. So LINSTOR is a software-defined storage, also a block storage orchestrator. In CloudStack, it is a primary storage driver. So you can run your virtual machines on it. LINSTOR behind uses mainly the technology of DRBD, which is also developed by Linbit. And Phil here will give you tomorrow a deep dive into DRBD and the technology behind it. And LINSTOR and nearly all projects at Linbit are open source. Bit for the architecture or how LINSTOR works. It's similar to how CloudStack is designed. I mean, from this management server and agents. So in LINSTOR you have a controller, which can be HA, which is the same thing as the management server in CloudStack. And then you have LINSTOR satellites, which actually do the heavy lifting of creating block storage for you on the host nodes or on the agent nodes in CloudStack. You can talk to the LINSTOR controller over an REST API. This can be also encrypted over SSL. And we have an GUI and a CLI application for that. And the API libraries for Golang, Python, what else? I think another one, yeah, Java, of course, because that's the one we use for the Apache CloudStack plugin. And then you have all the other third-party plugins like Apache CloudStack, which use this API. Also a deep, short dive in what LINSTOR objects you have. So you have nodes, which would be your satellites, like CloudStack hosts. Then you have resource groups, which is some kind of on top object to define roles for your storage. So what you want from your storage. You can define there how many replicas you want, for example. It's the simplest one. Then you can define more advanced rules, like if you have 2 racks and you don't want to have, or you want to have in each rack 1 diskful replica of this resource, as example. Then you have resources with volumes. So the volumes would be then your actual block storage, which you give to KVM. Like that's then in the end def DRBD 1 to how many volumes you have. Then snapshots, which represent, of course, snapshots of resources and volumes. Then we have storage pools, which are what kind of storage you're utilizing. So in the most cases, this is either LVM or ZFS. And we have one special storage pool driver, which is diskless. So LINSTOR can utilize, or DRBD, it uses DRBD, which provides you the storage on a node which doesn't have a disk at all, for example. So it's like a virtual disk for you, and you can read and write from there. And all of these objects share or have properties, and with these properties we can control certain aspects of how those objects behave, or how they have options to like I said in first resource groups, with such options or properties you can control if they all have to be on the same rack or on a different one, and such things. So the LINSTOR driver is in CloudStack since 4.17. It is KVM. The plugin itself is only for KVM. We have also an integration with XCP-ng, but this is utilizing more this the XCP-ng. I can't recall right now the API for it, but it will just use the XCP-ng API, and the driver runs actually on the Xen hardware or the XCP-ng hardware. But the plugin in CloudStack itself is just for KVM. It's a primary storage. It's supported in 4.17 volume snapshots and live migration. Then since 4.18, we added support for IAPS quality of service. So you can define when you create your primary storage how much IOPS your storage pool or primary storage has, and then the calculation is done by CloudStack when you specify your compute offering. And a small addition was that we added as I said, properties. There are auxiliary properties which can be set by users. To give you a better overview, if you will see later what I mean, like which volume belongs to which virtual machine, for example. That's what's in right now. And here is now what's upcoming in 4.19. This was already merged. So we added, before snapshots were only on the storage saved, so there was no backup to the secondary storage. Now we have an option for that, so we can turn it on, and then snapshots will be converted to CUCO2 files, because LINSTOR is primary, is only raw storage, so it's a raw image. And it will be converted to CUCO2 and stored on the secondary storage. And I also added resource names or property names for the templates as images. So before CloudStack creates a virtual machine, it has to first copy the template onto the primary storage, and from there it can clone your actual instance image. And now that first template image also gets a name, so you can see it easier in LINSTOR. But I'll show you. We have a live demo afterwards, after my presentation is done, which is already I think, nearly the last slide. And then what's planned for the next or after 4.19, because I think CloudStack already has enough features for 4.19 planned and still in a tight schedule. So for 20 VM-snapshots, I already have this working, but we'll wait for the pull request for 4.19 to be finished. Then there will be a little bit expanding on this feature here, that we also support backup snapshots on non-hyperconverged setups. So if CloudStack doesn't know about the storage node, because then I have problems to actually execute any code on those storage nodes which are not known to CloudStack, because I need the agent to work for me. But we have already a a workaround for that in mind. Then this was something I also planned for the plugin, but I will probably more do in LINSTOR itself, which is right now LINSTOR will clone your template image efficiently, or as efficiently as it can be. So like for LVM, this would be a copy of your LVM snapshot, LVM fin, and same for CVS. This has one drawback that it always will clone on the same disk full nodes and same storage pool as it currently is. And with this addition, it will be then copied by, let's say, in the least resort DDD, but has then the advantage that it can also go to other storage pools or other resource groups. And we will also check on the ability to do virtual machine memory snapshots. But this is just planned, and that's where the question mark here is. So, yeah, now we'll show you some of the new things. Whoa. Sorry.
Can I pose a question from online?
Sure. Yeah, sure.
Alexandra asks, does LINSTOR keep volume snapshots on primary storage or removes them after copying to secondary?
With this new option in 4.19, it will remove this snapshot from the primary storage and only keep the backup snapshot on the secondary storage. Yeah. This will be not sure I can hold the microphone and also talk, but I will try. Pardon? Oh yeah, that would be nice. Yeah. All right, so I try to make this a bit bigger. Okay. So this is a hyperconverged setup I have here. It consists of 3 CloudStack hosts, 1 management server. These hosts are on 61, 62, 63, and the management server is on another node. Exactly. It only has as primary storage LINSTOR, so I didn't set up any tags, and so everything will run on LINSTOR primary storage. Secondary storage is plain NFS, which runs on the management server. What else? Yeah, system VMs are already running on the primary storage, and so we'll also make this a bit bigger. Oh. Here we go. Oh, wait. No. Is this good to read? Yeah. Okay. So yeah, LINSTOR setup looks like that. I have a controller, which is, for simplicity, running on this CloudStack 1 host, which I am logged in right now. It consists of those 3 CloudStack hosts, so 1, 2, 3. Then I have 1 resource group for CloudStack, I mean, especially for CloudStack. This is with a place count of 2. So this means if I create a new resource, or CloudStack creates new images for me, it will have 2 diskful replicas, and it keeps also 1 tiebreaker, which is a diskless node for quorum to avoid split brains. Then what I was talking before about those properties to show which image belongs to what virtual machine. Because LINSTOR uses the UIDs from CloudStack, which are not very nice to read or remember. So you have here, in addition, the name of the CloudStack object. So root 23 is this ID here, and it belongs to the S23 VM, which is the system VM here. So this is the secondary storage VM. And here, this is this new addition in 4.19 that now also template get a name. This didn't happen in 4.18. So it's easier to find out which resource in LINSTOR belongs to what object in CloudStack. So if I show you the LINSTOR resources, you can see where which resource is located. I mean, in this setup, you will always have per volume in CloudStack 3 resources, because we want to have 2 diskful ones, and 1 will get a tiebreaker, diskless node. Or here it's a diskless, here's the tiebreaker. So it seems here I actually wanted to have it diskless ones here, and it keeps that information. And here you see it's in use, and that's where our system virtual machines are running. And so what I first wanted to show you here is if we now create a new instance, I have here an Alpine Linux template, small instance. I will give it a small data disk additional to the root disk, and call it CloudStack Collab and launch. So here we'll see that there is a new, or there will be a new one. So that's root 31. So yeah, the root is here, data is here. Oh, it's already running. Let's check. Booting. So we can see now root 41 is on 5B7. So yeah, it's running on host 3. Here as a diskless. Takes some time. Oh. I must say I have not the best track record for live presentations of CloudStack. So in 3 attempts, I failed 2 times with an error. Okay, this is running. Now I wanted to show doing this new feature, which will not come in for 19, but in for 20. That is take VM snapshots. So yeah, we don't support memory snapshots yet because we need a place to store the memory and we have to find out a way to do that. So doing a frame snap. In LINSTOR you can check that with it's a snapshot list. And what here is the special thing is that the virtual machine has two volumes, the root disk and the data disk. And this now gets a snapshot of both of them. Well, that's not what I want. So, storage. And of course it shows also here. That's one thing. Then the other thing is now this option, which is now will be part of 4.19, is this backup snapshots. Here it's enabled already. That will back up volume snapshots to the secondary storage. So if we do an additional snapshot of this data volume, you will see it. It will for the time, so it will first create a snapshot on the actual storage. That was also the question from the online. And then it copies from that, and then it will delete it. And now it should be on the NFS storage, so we could check that. So it will export. Yeah, so here is our backed up image then as KUKA2 file. And that's what I wanted to show, and thank you. Any questions?
Yes, a lot of questions. I also have 3 questions online.
Okay.
So, Ari.
Thank you, first of all. A bit of a side question, like how do you make sure the Linbit plugin with CloudStack is always working with respect to CloudStack versions? Like how often do you test the plugins with CloudStack?
Good question. No, before a final release comes, a release candidate, I usually try it myself. I already started now, or in the last month, to create a setup. I can spin up a CloudStack setup fast, and also was planning to write some kind of unit test for that, or integration tests.
Thank you for your talk. My question is, can you create a volume snapshot from the VM snapshot? I know it works for NFF-based storage.
I don't know it, but I guess because I think there are no special interface calls for that, so I guess this will be just done, but I can also try if you want live. I'm not afraid. Maybe I should, but so yeah. Okay. If not, I will implement it because this is not planned for 4.19 anyway. So.
Maybe the demo code spring with. By now we have 4 questions online, by the way. We'll await the result here.
Okay.
Good demo, a real demo. So, let me quickly
As I said, it's
go
not
through the 4 questions online. Michael asked, does the LINSTOR integration support the CloudStack volume encryption feature?
I guess so, because we are, I guess, a layer below that. So I don't know how the encryption feature is done in CloudStack, but I think so, yes.
That's up to experiment until now. Aung Toon asks, LINSTOR is working on 3 nodes. Let us know 2 nodes are working on the same spec server. If one node is on a different spec server, how does that work?
As long as they support, or as long as DRBD runs on them, yes, there shouldn't be a problem. And
It's more a software
it's more
question
a
than a hardware question.
Yeah,
Okay.
it says we have no really not hardware requirements. So
Alexander again asks, what is the minimum number of hosts recommended for LINSTOR as primary storage solution?
at least 3, because to have this quorum feature. I mean, you can run it on 2, but then you would need to set up fencing to be really safe, and that you don't want to do that. So 3 is the minimum.
And then the last question online. Aung, again, diskless is keeping only information, or 2 nodes are cracked, diskless is working on? Whoa. I'm not sure I understand the question, do you?
No, but I'll try to explain what diskless is. So diskless, no, it doesn't have any information stored. It gets that from the diskless, diskful nodes over the network. So, yeah, I don't know if that answered that, but
you can add that you can use a Raspberry Pi as a node.
yeah. So
that has the diskless.
I think you answered it to me. It's basically down to you have a 2-time copy of the data,
yeah.
Irrespective of whether the client is diskless or not.
Yeah.
Right. We're through the questions online, and we have for another 2 minutes, if there's a question.
Thank you for your presentation. I want to ask you, how do you replicate data between these nodes? I think you are using DRBD, and as far as I know, we have lots of problems about split brain in DRBD. How do you handle this? And the other question is, what is the interface of the storage to the KVM? Which protocol do you use? iSCSI, NFS, another thing?
Okay. First question, yeah, this is primarily now solved with having a quorum node. So that's why you should use at least 3 hosts or nodes. Then you have this quorum vote and only 1 survivor if there is a network split or something like that. And this works pretty good. And the second question is, we give the actual DRBD device to the KVM. So in your KVM XML, you would then have dev DRBD that you get the raw block device to KVM.
There is another question. So.
Well, I don't have a question. I have a comment to one of the previous questions, and that was if CloudStack disk encryption is supported. To that, I want to add that we have disk encryption in DRBD itself, and that can be enabled on the resource group. So, and 2 implementations, SCD and DEncrypt.
Okay, we're through time, but I'm pretty sure Rene will be around for a few more minutes today and maybe tomorrow. So go and find him, and please thank him for his wonderful talk.
Thank you.